Okay, the gray PLA arrived, so I finished printing the main body parts and other parts. I think I've printed all the parts, and I'll find out when I start assembling all this stuff. But as you can see here, I have the body back part, and it's already covered in the earlier video. This is the base, so the body back will slide up onto the base like so. I did break away a little bit of plastic. You can see right there where the clicker is. I just took my nippers and nipped a little plastic away because the top of the clicker was hitting the back of the body, and my first impression was that's not how I designed that. And so I broke the plastic away. After I broke it away, I went, you know, maybe I should have left that plastic there because it won't stop the clicker from working, and it would maybe sonically couple this whole clicker to the back shell of the body and maybe make the clicking louder, which would be desirable. My original design was to have the clicker just sound through the base of the unit, which is the way the original toy works. Basically the clicking is coupled down to here and then resonates through all that. Here's the body front. I'm printing these parts flat on the printer this way. This piece and this piece are side pieces which I glue in afterwards, so if they're not there then this can sit flat because I want to make sure there's no warpage. I want these two halves of the body to be able to fit together with a decently tight seam. It's not going to be perfect, but it's to emulate tin toys, and they always had a seam, visible seam. We'll see how that goes. So there are some clear parts that go into this. For example, here is the red lens for the spark window, and this is printed in translucent filament so that when the LEDs are back there flashing, it'll light that up, and that'll just get glued in place. And then the eyes, they're both the same. I've already glued the LEDs into them, but basically they just will get inserted from the inside of the head like that to form that, and of course get glued into place when the time comes. Now I can't put any of those parts in yet because I need to paint all these parts first, and we're going to talk about that in just a second. As far as the arms go, I print the arms laying flat as two pieces and then simply glue the two halves together. And here's one glued together. This is an arm axle piece here. It has a flat. See that? Does that show up? That flat sits on the printer bed that way, so I'm able to print around without supports. And the flat allows me to key things on there, like for example this cam, which is going to be used to not only move the arms but also move the meter movement. Can then slide on the shaft and I can adjust it where it needs to be, and once I get it where it needs to be, I'll put some glue on either side of it to hold it in place. And I didn't key the arms to that flat yet because I'm not sure what that position is going to be. So what I'll do in the end when I know is I'll probably just put some glue down inside the arm hole, push it on and turn it into the right position and glue it on that way rather than worrying about keying it too much. The earpieces printed in a red PLA. Now I happen to have had these hoops and these parts from some repro robots, and not sure of what I'm going to do if I have to make more of these, because I don't have more of these. I guess I'd have to try to find some chromed metal and try to fashion my own, which would be a real pain. Or of course you could buy the repro toys, but that's kind of a waste to buy them just for that. Okay, we have the meter part, and you're looking at three different pieces here. The black is the main frame for the meter. Then this artwork, I had taken a picture of the meter movement on the one that I had on the bench the other day, Ozzy's Diamond Planet, But I didn't take a very good picture because I figured I would just generate new artwork on my computer and print it. But then I found that my program that I used to generate that kind of stuff in no longer works with the newer systems on my computer, so I don't have a way of generating that artwork unless I want to buy a program, and I don't want to buy a program. So I just put in the rather bad picture that I took of the meter, and it'll suffice for now. I mean, it looks fine actually. And printed the needle pointer right here, and there's a number 2 screw that I screwed into the needle pointer, which comes to the back side and goes to this gear. And then this gear, so if this gear moves, the needle's going to move. Now to move that gear, there's going to be a linear gear. So envision this sort of action going on. Because I have a vertical action coming to move the arms, so that I need to transfer that vertical action into the meter movement back here. So to hold this in place, there's this back piece. It allows this screw, which is going to be like so. See how that fits in there like that? And I'll just line that up on there. And then these 2 parts, the gray and the black, I printed them in different colors to make it easier for you to see everything, would get glued together once everything was lined up. Because then, as this moves, had I assembled it correctly, let's move this a little bit more and make it easier to demonstrate. So there we have it. When it's all lined up, gravity will let that drop, and it'll give me the meter movement from the vertical movement from the arms. Is a little lever that goes right where my finger is, so just like if the arms axle is tipping, it'll move the meter movement. So those are the basic parts. The only reason I haven't gone further is because, like I said, I need to paint the front, the back, and the base part first before I start doing any detailing. And I wanted to try to get as close to the original color, that the one that I had on the bench that was here. And they used to sell a hammer tone is the effect. Hammered is a word that's used by Rust-Oleum, I believe it is. And then there's Hammerite, which is another company. And even Krylon makes a hammered paint right now. It's just kind of a paint with a fisheye look. It makes things look like metal. I've used it for years. The mechanical band out in the Robothut, if you've ever seen it, it looks like the entire thing is made out of metal. The entire thing's made out of wood. And I simply covered it in hammer tone paint. But, for example, if you go up on the eBay, you can see here there are people that are still selling. This is the Hammerite, hammered light blue. So if the light blue is right, then great. But they have a buy it now of basically $125, plus then you pay another $5 shipping for 1 can. That's not a 6-pack or anything else. That's 1 can, because they basically quit making this stuff back in 2009. And that's fine. It's a little expensive for a rattle can paint job. I think what I'm going to try, let me see if I can find it down here. It's down here somewhere. Well, anyway, down there somewhere there was a Verta green, they call it, but in all the pictures it looks blue. And the robot that I had on the bench was a blue-green in color. So I'm thinking I'm going to try that. They wanted $25 for it. Again, it's discontinued, but $10 shipping, so I'm up to $36 for the paint job. So I went out and ordered a can of that. If it arrives, if the weather warms up enough, I will then attempt to paint these parts with the Verta green hammered, and we'll see how that looks. Now I can still just get the normal hammered silver, which I'm sure would look fine, At the local Home Depot, and even Walmart has a version of it in Krylon for less money. So that can always be a fallback if the Vertigreen doesn't work out. But I'm hoping it will, because like I say, the one I had on the bench wasn't really light blue. It was kind of a light blue green, kind of a turquoise hammered. So I'm kind of hoping that if the Vertigreen is a real deal and not a rip-off, that or if it hasn't gone bad in the can, being that it's more than 10 years old in the can. There's a lot of ifs there. We'll have to wait and see. But that's the next step, be to get those parts painted. Then we can actually start doing some assembly, and we can take it from there.